Welcome to 2.4, the second part of this. So, in the second part of this, what we're doing is we have formulas, and we're trying to use the formulas to solve for particular letters. So that's what we're doing here. So, if you notice in this first one, we have y equals 10 minus x, and we're trying to solve this for x. Well, the idea is the same if we had something like 7 equals 10 minus x. If we're trying to solve for x, we're trying to isolate this x right here. So if we want to isolate the x, we need to get rid of the 10. So we're going to subtract 10 from both sides. So after we do that, 7 minus 10 is negative 3. Here our 10's cancel. And then we bring down our negative x. And then if we're trying to solve this right here, we divide by negative 1 because negative x is negative 1. And we get x equals 3. So notice, we isolated the variable, and then we got the coefficient to be 1 right there, and we just get our x. So the same thing's going on here. Now, the same logic is going to apply to this problem. When we're trying to isolate x, we need to get rid of the 10. So if we subtract 10 from both sides, we're going to do that. Now, the difference here is y and 10 are not like terms. So we can't specifically combine these. The left side is just going to be y minus 10. The right side, when we subtract 10 from 10, we get 0. So our negative x carries down. Okay? So then the last thing we want to do is divide by negative 1 because we want a positive x. Okay? And when we divide these terms by negative 1, we do them individually. So we divide the y by negative 1, that's a negative y. Divide the negative 10 by negative 1, that's a positive 10. Negative x divided by negative 1 is a positive x. And that essentially is what we're looking for here. We've solved this for x. So we could write this like this, that's fine, or we could write this as x equals 10 minus y, or we can have negative y plus 10. These are the same things. Notice the 10 is positive here, the 10 is positive here, the y is negative here, the y is negative here, and we're good. And there's not specifically a way to check your answer. You're not going to plug this in for the x, but if you did, you would notice that you did get something true. So kind of moving over to this one here, if we're trying to solve by equals ax for y, by is b times y, ax is a times x. If we're trying to isolate the y here, we need to get it all alone. So if we have b times y, the way we're going to undo this multiplication is with division. So divide this by b, divide this by b. b divided by b is 1. So on the left side, we just get y equals. On the right side, well, once again, a, x, and b are not like. We can't really divide anything, so we just get ax over b. And that's the solution that we're looking for there. So moving on to the second row of them. If we have a equals a plus b plus c all over 3 for c, we're trying to isolate this c right here. So in order to get the c alone, we are going to try to get the a plus b plus c alone. And really, it's a plus b plus c divided by 3. So we want to undo division by 3 on this right side. So that means we're probably going to have to multiply this by 3. And we're going to have to multiply the left side by 3. Whatever we do to one side, do we do to the other. So on this left side, we have 3a. On the right side, this 3 cross-cancels with this 3, leaving us with just a plus b plus c. So now we want to get this c all alone, so we need to undo plus a and plus b, or a positive a plus b. So we're going to subtract a and subtract b, but whatever we do to one side, we have to do to the other side. Subtract a, subtract b. Now, we are assuming this is case sensitive, like uppercase a and lowercase a are different. And in fact, this a stands for average. How would you find the average of 3 things? Add them together, divide by 3. So these are different a's. So because this a and this a are different a's, we can't combine those. They are not like terms. So we get 3a, we have our minus lowercase a, minus lowercase b, that's a b right there. This equals a minus a is 0, b minus b is 0, so that equals c. So we have isolated the c. There's just one of those, and we are done. Okay, so moving on to this next one. We have y equals mx plus b, and we're trying to solve this for x. So if we're trying to solve this for x, we're trying to isolate the x. So we need to get the x alone, which means we need to get the mx alone first. In order to get the mx alone, we need to get rid of plus b, so minus b, minus b. Now, on this left side, y and b once again are not like terms, so we can't combine those. We just have y minus b equals mx carries down because we haven't done anything to that. But our b minus b is 0. Those have canceled out, so this is where we're at. So the next piece is mx is m times x. We're trying to isolate the x, so we need to undo the multiplication by m. So we're going to divide by m, and we're going to divide this by m. M divided by m is 1, so we're getting x. Now notice, over here, y minus b and m, none of these are like. We can't really do any division, so we can write this as y minus b all over m. And that's a legitimate way to leave that. Now, there is another thing that you could do. You could write this a little bit differently. You could write this as x equals, that's a better, we're not really getting great equal signs here. So, you could write this as x equals, now when we have this division here, we could write this as y over m minus b over m. And sometimes it might be more advantageous to write it this way. In this, these are actually the same thing. And you can notice, because if you're adding two fractions, you need a common denominator. Do they have a common denominator here? Yeah, the denominator is m. And when we do this, we could write this as y minus b all over m, which is this representation. So both of these are equally valid, and both of them are correct. I would give credit for either of those things. My math lab, on the other hand, might want a particular one, so you might have to play with that a little bit. So I did want to bring that to your attention. This next one, we have I equals PRT, which is really P times R times T. If we're trying to solve this for R, we need to undo multiplication by P and multiplication by T, and we can do this all at once. That is, we could divide by P, T, we could divide I by P, T as well. Now, P divided by P is 1, T divided by T is 1. So on the right side, the p's cancel, the t's cancel, we just get the r. On the left side, we have I over pt, and we've isolated our r. We can't divide I by p or t. There are no like terms to combine, so we're done with this. And that's that one. Now, the last one that we have is this. V equals 3k over t. So in order to solve this for t, what we have to do is multiply by the lowest common denominator again. And generally, like, even if we look back at this problem, like right here, really, 3 was the denominator of the right side, and 1 was the denominator of the left. So we did multiply by the lowest common denominator. The 3 canceled with 3 there. This 3 doesn't really cancel with the 1 right there, but we multiply both sides by the lowest common denominator. We're going to do the same thing whenever we have, this is actually known as a rational expression. Rational meaning ratio or fraction. So that's what kind of expression we have here. So the lowest common denominator here, right, this is v over 1, between 1 and t is t. So we're going to multiply both sides by t. So if we multiply the left side by t, we have to multiply the right side by t. Now good news, t times v is just tv. And I'm just going to caps right now because we don't have any other t's here, so hopefully it won't be too ambiguous. Now on the right side of the equation, t is a t over 1, and t cross cancels with t, leaving me a 1 and a 1. So on the right side, we just have 3k. Now, if we have tv, or t times v equals 3k, and we're trying to solve this for t, we need to undo this multiplication by v. So we want to divide by v, and we get t equals 3k over v, and this is the solution we're looking for. Now I'm going to put it in a cube. So I know that some of the times it doesn't make sense exactly why we're doing these things, but this is really going to help in the next module. When we start graphing lines, we're going to have to manipulate equations that have multiple variables in it, and this is to get you ready for that skill. So hopefully this kind of made sense to you. If not, watch the video again, send me an email or something like that, and I'll see you in the next section.